Happy Wednesday, hump day.
Yay! Sports day. Right?
Yes. All right. So we are now on fractions part 3. Flip to page 10 and let's get started.
Yeah.
All right. So this is our last day of fractions before we move to decimals tomorrow. So we just finished reviewing adding and subtracting fractions. All of those were like denominators. So the only unlike denominators that you had to do for that in fourth grade is the tenths and hundreds. And that's super simple as we've shown you here because 10 is a factor of 100, so you just multiply by 10 to make it equal to 100. So pause this and grab two colors if you don't have two colored pencils right now. All right, so we have 8 hundredths plus 5 tenths. That's the original problem. You cannot add 100 in tenths because they are unlike, right? So to make us be able to add the fractions, and you never add the denominator anyways, it's just the numerator, you have to multiply the tenths by 10 to make it 100. So we've done that there by drawing in the little blue 0. So now that they are both hundredths, whatever you do to the top, you have to do whatever you do to the bottom, you have to do to the top, or vice versa. So 5 times 10 is 50. So you're adding that 0 in. You have 8 and 50 hundredths, which together equals 58 hundredths, but you're not going to leave it that way. So we know that hundredths can easily be divided by 2. So 100 divided by 2, so now we're simplifying it, is 50, and then 58 divided by 2 is 29. And then you can see, or in decimals, when you're adding it, it's, remember how we read these correctly, 8 hundredths and 50 hundredths. So kind of like the hiss on the end. When you're adding the decimals, remember you must line them up. So you can see that it's nice and neat. The decimals are lined up. So 8 plus 0 is 8. 0 plus 5, 5. Bring that decimal there. If you don't have the decimal, then the whole thing is pointless. And then you can put the 0 in the front or leave it just as decimal 58, which we read 58 hundredths. All the same thing. We just showed you many different ways for how to do it. Good?
Great. All right, now we're moving to multiplying fractions. So we can multiply fractions using a couple of different strategies. So the first two that we're going to talk about is using repeated addition and then using our fraction bars. So we know that 1/5 times 4 is the same thing as doing 1/5 plus 1/5 plus 1/5 plus 1/5. And here's a model of what that looks like. So if I take each of those fifths, which is the blue part right here, I end up with 4/5. So in the red one, I just put all 4 of those together. So we could see that 1/5 times 4 is really just 4/5. With fraction bars, if we have a number like 15, if I'm finding the fractional part of a whole, right here I have 2/3 of 15. Remember, the of means times. I can take that rectangle and split it up so that I'm in 3 different sections. So my denominator tells me how many sections to make in my rectangle. The whole rectangle needs to be worth 15. So if I look at each of the 3 sections, I need to think, what is 15 divided by 3 to figure out what each piece represents. So that's where I got the 5 in each section, because 5 times 3 is 15. And if I'm looking at 2 of those sections, that would be 5 plus 5, which is 10. So 2/3 of 15 equals 10 whole. Good?
That's my favorite one to do. I like setting it up like that.
Me too. I love that one. All right, and then there are a couple of other strategies. Well, one other strategy for multiplying fractions, and it's kind of the easiest one. You want to take it, Mrs. Moore?
Sure, yes. So the original equation, so 3/4 times 12, you make 12 have the denominator of 1. That's the same thing as saying 1 12 times. So 12 once is equal to 12. So then you just multiply it across. So 3 times 12 is 36. 4 times 1 is 4. And you have 36 fourths as your answer. And if you know your facts, you can go ahead and make that equal to 9.
I was
Right?
just going to say, I wish that I had put equals 9 because I don't like it as an improper fraction. We also could have done the fraction bar for this one because I know that I could take the whole 12 and split it into fourths. So that would work for that one as well.
So 36 or 36 fourths is equal to 9. So if you had either one, you're good on that.
Mm-hmm. All right, and then multiplying fractions, what word problems sound like? So this was the hardest part because we know that fractions are division, so the multiplication problems sound a little bit weird. They sound like you're dividing or subtracting. So it says there are 20 students on a soccer team. Of those 20 kids, so I'm looking at out of those 20 kids, so that keyword of, if I'm doing of an amount, it means I'm multiplying. Of those 20 kids, a fourth of them have scored a goal this year. And then it asks the question again, how many students have scored a goal? So anytime it repeats like that, it's looking for a number. It's looking for you to multiply 1/4 of the 20 to get an answer. So I would set that up as 1/4 times 20. I could use a couple of different strategies. I could use the box method, or I could just multiply straight across. And without doing it right in front of me, I believe that's 5 students. I would take 20, cut it into fourths. 5 would be in each piece. So 5 students have scored a goal this year. Remember, it could also say how many have not scored a goal.
Yes.
So that would be 1/4 of 20, but then I need to subtract it out, or do 3/4 of the 20. So we've done a lot of those types of problems. You'll do a lot more of those next year.
Awesome.
And then here we go. Pause us, come back to us, and here we are.
Get out. And here we go. All right. Ooh, number 1, baking. A lot of us have been baking during this time. So each cupcake needs 5/8 of tablespoon of frosting. The word each means we need to multiply. So how much frosting will there be needed for 40 cupcakes? So 5/8 times 40. Notice we set it up just to multiply straight across. You put that 1 on the bottom. So 5 times 40 is 200, and then 8 times 1 is 8. I'm not going to leave it as 208 because how in the world would you actually measure that out? That's crazy.
Oh, that would be
So
crazy.
you can see that you divide it. So 200 divided by 8, you know how to divide, and you get 25. So then you look at your answer choices. Awesome. 25 tablespoons is there. So you're going to be doing a lot of that, measuring it out.
A lot of cupcakes. All right, number 2, what is another way to write 2/5 plus 2/5 plus 2/5? We know that repeated addition is multiplication. I have 2/5 3 times, so it's a 2/5 times 3.
Yes. All right, so number 3, this one is visuals. So you're looking at the picture, and we can see that it's kind of hard to see, so I'm going to look over at mine. You have 2/3, 2/3, and 2/3, correct?
Mm-hmm.
So that's saying 2/3 3 times. So that would be the same thing as saying 2/3 times 3.
Mm-hmm.
And I'm looking at the answer choices, and the only one that I see for that is B. So 2/3 times 3. When you actually work that out, here it gets to equal to 6/3, which is equal to 2 wholes. So then it kind of matches the picture on the right in both of those. Even though they're split into thirds, 2 are represented, and that third that is not shaded at all is just there. So 2 wholes. That one was kind of hard to explain.
Mm-hmm. Did great. Number 4, another recipe. We need 1/3 of a cup of oil. How many cups are needed to make 8 of the recipe? So I need 1/3 8 times. So I'm doing 1/3 times 8, which gives me 8/3. Because we're good students, we changed it to a mixed number and got 2 2/3. Looked over, it wasn't there, but 8/3 is. So we chose that one, and that is the correct answer.
That's a little tricky because some of the answers are glad and some are mad. So you
Yeah.
got to be careful on that one.
Yeah.
All right, pizza, yum. So another visual one. So the shaded part represents the leftover pizza. So that's how much left that you can eat later. How much pizza remains, you can see. First, you have to know what your pizza is split into. They split it into sevenths. And the first one shown is 4/7, 4/7 again. And oh, wow, 4/7 again. So that's the same thing as saying 4/7 times 3, which we did below. 4 times 3 is 12. 7 times 1 is 7. 12/7. We're not going to leave it mad. We want to make it glad. And when we follow those steps, we have 1 and 5/7. And that is how they did the answer in the happy format. So C, 1 and 5/7 pizza is the correct answer.
All right, and we're done. See you tomorrow
Yay.
for decimals.
Decimal.
Have a good day, everybody. Hi, Mrs. Moore.